In this video, we'll take a look at Unit 2, Transformations of Linear Functions. The general form of a linear function is y equals mx plus b, where m is the slope and b is the y-intercept. A parent function, which is what we're going to put in our lines here, a parent function is the simplest function in a family. All linear functions come from the parent function, y equals x. Important facts about the parent function. It goes through the origin. We should know that, as our y-intercept is not listed on our parent function because it is 0, so it goes through the origin. The x-intercept and the y-intercept is at the point 0, 0, that origin. And our slope is always 1 in the parent function. Remember, your slope is that constant right in front of x, or the coefficient of x. Right now I don't have 1, but it's there. It's an imaginary 1. Transformations can occur in our graphs, and they can either be a vertical transformation, or we can go ahead and change the slope. By examining the changes made to the m and the b in our equations, you can determine which transformations have been applied. A vertical translation is showing how we're changing the b, the y-intercept, and how it moves the graph up or down along the y-axis. Slope manipulation shows how we're changing the m, or the slope, and it alters the steepness of the line. So again, your slope manipulation changes how steep your graph is. Your vertical transformation moves the graph up or down. If we're going to go ahead and change the b, we're changing that vertical translation. We're moving it up or down. If b is greater than 0, we're shifting up. If b is less than 0, then we just shift the graph down. The slope stays the same. So if we describe the transformation to the function y equals x plus 2, this graph, we've added 2 to the parent function. Remember, the parent function is y equals x. So what did we do that's different? We added 2 to it. That's shifting up 2 units from the origin. It now makes our y-intercept, instead of being 0, 0, it makes it 0, 2. When we describe the transformation to the function y equals x minus 8, compare it to your parent function. What's different? We went ahead and subtracted 8. That's going to be a shift down 8 units from the origin. You have some examples here. Identify the transformation for each given equation and compare it to the parent function. Take a moment to pause the video and try that. Y equals x plus 5. Since we added 5 to our equation, this is a shift up, and the shift is 5 units up. Our second one, we have a minus 4. We shifted down 4 units. For y equals x minus 3, again, we subtracted. We're going down 3 units. And our last one, we have a shift of positive 2. That's a shift up 2 units from our original parent function. As we talk about slope manipulation given an equation, we're changing the m. And the slope from our parent function is 1. But let's see, we're going to vertical stretch or compress. Stretch means we're getting steeper compared to the parent function. The slope of a given function is going to be greater than 1. We are stretching. When our slope of the given function is between 0 and 1, we're compressing, or make it less steep. So we have less steep, that's a compression. Our slope is between 0 and 1. With a stretch, we're greater than 1, and we're steeper. So let's take a look at what that might be. Describe the transformation of our function y equals 2/3 x. In this case, our slope is 2/3, and it's in between 0 and 1. You can always pop that in your calculator and get the value, the decimal value, and see that it's a decimal. between 0 and 1, 0.6 repeated. Therefore, this is a compression, and our graph is getting less steep. In our second example, we have y equals 4x. 4 is greater than 1. So now we're stretching our graph, and this is going to make our graph more steep. Go ahead and try identifying the transformation and compare it to your parent function. We have y equals 1/2 x. That is less than 1, so it's a compression, and we're going to make that less steep. Y equals 3x. 3 is greater than 1, so now we're stretching and making our graph more steep. Y equals 4x, again, is a stretch because 4 is greater than 1, and it's going to be steeper. Our last example, y equals 1/5 x. 1/5 is less than 1. It's in between 0 and 1, so that's a compression, and we're becoming less steep. We want to also be able to identify this based on the graphs that we have. So it says, describe the transformation of y equals 3x minus 2. Graph the function. I already have the parent function on my graph, so now we're just going to add this new graph to it. And y equals 3x minus 2. From our previous lessons, we should remember that -2 is the y-intercept, so we're going to dot that. And then we use our slope of 3 to go up 3, 1, 2, 3, and over 1. I'm going to give myself a couple more dots. And then graph the line. Oops, I missed all my points. Try that one more time. Okay, pretty good. So now let's take a look at what we have here. The slope of the new graph is steeper or less steep? Let's see, 3 is greater than 1. That's going to make it steeper. And you can see that my red line there is definitely more steep than the original parent function. It's a steeper hill to climb. Then a new graph shows a stretch or a compression. Well, because it's steep, it's going to be a stretch. And now we'll look at our y-intercept based from the parent function to the new red line. Did we shift up or down? We were at -2 for the y-intercept shift, so we shifted down. Next example, it says a function is graphed to the left. A new function has a slope that is twice as steep as the function graphed, and its y-intercept is 3 less than the function graphed. Graph the new one. So let's go ahead and take a look and see what our original function is and what its slope is and the y-intercept. So here I can see this is my y-intercept. It's at +2, and I'm looking for my slope of this. So let's see. Here's a dot, and I want to find the next dot on the line that hits the grid nicely behind it. That looks like I'm going up 1 and over 2. So the slope of my original line is 1/2. It says the new function will have a slope that is twice as steep. What's the new slope? Well, my original slope was 1/2. If I want to go twice as steep, then I'm multiplying it by 2. Remember that when you multiply a whole number by a fraction, we can put a little 1 underneath that and multiply straight across the top and straight across the bottom and simplify. Our new slope should be 1. Actually, I'm going to go ahead and make that a different color. Let's go blue. The new function will have a y-intercept that is 3 less than the graphed function. Well, here was our original. It was at 2. If we are 3 less than the original, we're going to subtract 3 from that. 2 minus 3 is -1. The y-intercept will be at -1. Now we can go ahead and graph this new line. We have a y-intercept at -1, and we have a slope of 1. So we're going up 1 and over 1, up 1 and over 1. I'm going to give myself a couple extra dots here. That just helps me graph a straight line. What is the equation of the new function? Well, by finding the slope and the intercept, we should be able to write our new equation as y equals, what's our new slope? Our new slope is 1. And what's our y-intercept? It's -1. So we can have this, but we don't need that 1 in front of the x, so you're probably going to see it more like this.